In this video, we're going to cover Interchapter D, where we will discuss the naming of compounds with a functional group that calls for a suffix. So in this first part, we're going to talk about the nomenclature for carboxylic acids, acid anhydrides, acid halides, or oftentimes just acid chlorides, amides, nitriles, aldehydes, ketones, alcohols, and amines. So for this group of functionality, we will be using the setup we've used previously. We will have a prefix, followed by our root, and then a suffix. So just like we've seen in previous nomenclature chapters, the suffix is going to tell us about the functionality associated with the substance. So each one of our functional groups will have a specific suffix ending. The root is going to be the longest carbon chain, or the parent chain, that we have been talking about. So once again, you'll have to find the longest alkane, alkene, or alkyne chain that contains the functionality that we are dealing with. The prefix is then going to be all the substituents, and also we will need a locant with all of those to tell you where on the parent chain you will find these substituents. So we're going to be looking at our different groups, and we're going to be telling you whether or not we're going to drop the E associated with the parent chain, and then the suffix that we will add for that functionality. So the first functionality is our carboxylic acid. Remember, our carboxylic acid is the carbonyl that is attached to an OH. For this, we are going to drop the E on our parent chain, and our suffix will become oic acid. For the acid anhydride, this is where we have two carbonyls, and they are separated by an oxygen. For the acid anhydride, once again, we will be dropping the parent chain, and our ending or suffix becomes oic anhydride. Please notice with both of these that it will be two words. The acid becomes a second word, and anhydride becomes a second word for both of these. For the acid halide is our carbonyl that is attached to a halogen. The most common halogen that we will be using will be chloride, so the X would become a Cl. We will be dropping the E associated with our acid halide parent chain, and the ending becomes oil halide. So once again, if our halide is the chloride, it would become oil chloride. For the amide is where we have our carbonyl, and it is attached to a nitrogen. That nitrogen is then attached to two other groups. Those groups can be hydrogens, or they can be carbon atoms. Once again, we are going to drop the E on our parent chain, and the ending becomes amide. For the nitrile is where we have our carbon that is going to be triply bound to a nitrogen. For the nitrile, we are not going to be dropping the E ending because the suffix becomes nitrile. So since we'll have two consonants side by side, if we drop the E, we will not drop the E for this functionality. The aldehyde is where we have our carbonyl, and our carbonyl is attached to a hydrogen. We will be back to dropping the E on our parent chain, and the ending becomes Al. For our ketone, we have our carbonyl that is attached to two carbon atoms. We will again be dropping the E on our parent chain, and the ending becomes -one. The alcohol is where we have the OH attached to one of our carbon atoms. We will once again be dropping the E on our parent chain, and the ending becomes OL. Please be very careful with your alcohols and your aldehydes. Make sure I can tell a difference between your A and your O. Aldehydes have an AL ending, where alcohols have the OL ending. So please make sure you are very clear. For the amines where we have a nitrogen attached to a carbon atom. That nitrogen then also has two other attachments, and once again they can either be carbons or hydrogens. We will still be dropping the E on our parent chain, and the ending becomes amine. For the last three functionality groups that we looked at, we need to use locants for each of these because they can be found anywhere within the chain. So we have to tell you which carbon atom they would be found on. For the functionality listed at the top, these are what we call terminal functionality. We do not need to use a locant because they will always be on carbon atom number 1 since they are terminal in nature. If you have more than one functionality, you will be using your Greek prefixes of di, tri, tetra, etc. to tell you how many of each of these that we have, just like we saw before with our enes and our ynes, our double bonds and triple bonds. If you end up using a Greek prefixes, you will not be dropping the e's. Our goal is not to have two consonants side by side. If we do have multiple of these, you will need to use multiple locants to tell you where all the different functionality is. So let's look at a few examples. My recommendation for you is that you pause the presentation and you try these examples on your own and then replay the presentation to check to see how you did. So for our first structure, our name for this would be 2s 5e hept 5-ene 2-ol. So 2s 5e hept 5-ene 2-ol. The S and the E are telling us about the stereochemistry associated with our structure. We have 7 total carbon atoms. The ene is on carbon atom number 5 and the ol is on carbon atom number 2. What you'll want to notice with our priorities here is that the functionalities are going to take precedence over anything that is an alkene or an alkyne in terms of the numbering for our compound. For example number 2, this is 2-ethyl 3-methyl pentane al. So 2-ethyl 3-methyl pentane al. And please make sure that you are very clear with the Al for the aldehyde. Example number 3 is 1-phenyl propane 1-one. So 1-phenyl propane 1-one. Since it is a ketone and does not need to be terminal, you need to make sure that you have the one locant for the carbonyl, for the ketone. For the fourth example, it is 3-methyl pentanoic acid. So 3-methyl pentanoic acid. Please make sure that you are still finding your longest carbon chain. For this example, our longest carbon chain goes up and around to make sure that it includes our functionality. The pentanoic acid, the acid functionality does need to be in priority number 1, which is why the methyl is in position number 3. For example number 5, this is butane nitrile. So please make sure that you recognize the E is still there for butane nitrile. In our nitriles, we count the C that is part of the nitrile functionality as part of the longest carbon chain. For our last example, this is pentane 1,2-diamine. So we have our amine functionalities, but we do have 2 of them, which is why we have the diamine. Also, please note that since we had a Greek prefix of 2, we left the E on the pentane parent as well. So pentane 1,2-diamine. So next we're going to talk about our esters. For our esters, they are going to be named different than the ones we saw before, where we had the prefix, we had the root, and then we had the suffix. For esters, we're going to name them in the form of an alkyl alkanoate. So remember, for our esters, we have our carbonyl. That carbonyl is attached to an oxygen that is attached to another carbon chain. So when we actually get ready to look at these, the R group that is attached to the singly bound oxygen, we will name this as an alkyl group, which becomes the beginning of our name. The portion then that contains the carbonyl, this becomes our alkanoate group and becomes the second word in our name. So we will name esters using 2 words. The alkanoate group, the way we will name this is this will have our prefix followed by our root followed by our suffix. The suffix for these will be the O8 suffix. For our esters, we will be dropping the E associated with the root, and the prefix would be for any other substituents that we would see on our R group. So let's look at an example for this. So in our example, our alkyl group is going to be an ethyl group. Our alkanoate group would be this group here that has 4 carbons associated with it. So it would be butane O8. So when we put the full name together, the full name for this would be ethyl butane O8. Again, making sure that it is 2 words, the alkyl word and then the alkanoate word. So next we're going to talk about amines and amides that have substituents or other groups, carbon chains associated with the nitrogen. So first let's remember what our primary is. So anytime we talk about primary groups, a primary amine would be a nitrogen that only has 1 R group associated with it. If we talk about our primary amides, this would be where the nitrogen that's attached to the carbonyl only has hydrogens associated with it. We can also have secondary amines. Secondary amines would have then 2 R groups associated with the nitrogen. The R groups may be the same or different. For the amide, the nitrogen would have 1 R group associated with it and 1 hydrogen. Tertiary amines would have 3 R groups associated with the nitrogen. Tertiary amides would then have 2 R groups associated with the nitrogen attached to the carbonyl. For naming these, we're going to treat the alkyl groups like any substituent. The locant we will be using is going to be an N. So anytime we have secondary or tertiary amides or amines, we would still have our substituents, which would be the R groups coming off of the nitrogen. The locant we would be using would be a capital N. Basically, instead of giving you a carbon number chain, we're going to tell you it's on the nitrogen associated with the chain. So let's look at a couple of examples. For this first example, this is an amine. So we have 2 R groups associated with the amine. They are both methyl groups. So we could say that this is a dimethyl. The locant is once again a capital N. And then we have our parent chain, which is 3 carbon atoms long. So our full name for this is going to be N dimethyl propane 1-amine. You do want to be very, very careful. We do need to use a locant for the amine because, again, the amine can come anywhere on the parent chain. So we need to make sure that in this one we're telling you it's coming off of carbon number 1. Those 2 capital N's are telling us that the methyl groups are coming off of the nitrogen atoms. The second group is an amide functionality, where once again it is going to be in a tertiary amine. We have 2 groups coming off of the nitrogen. So this is going to be an N-ethyl, N-methyl, hexanamide. For the hexanamide, the amide functionality is terminal, so we do not need a locant in front of the amide functionality like we did the amine functionality. So for all these functional groups, we do have priority levels for them. The highest priority is going to be dictate what the suffix is and the numbering pattern, basically starting at carbon number 1. Other groups become then substituents, where we would need a locant and a prefix associated with them. So I quickly just want to run through this table in terms of our priorities. So priority number 1 will be the carboxylic acid. We do have a prefix if we have multiple of them that we can call this a carboxy group. Priority number 2 is going to be an acid anhydride. We do not have a prefix for an acid anhydride because it will typically always be your suffix functionality. We do also then have our esters, which again we do not have a prefix that is commonly used for an ester because we have that alkyl alkanoate type of naming. Next is going to be our acid halide or acid chloride. So it would be a halide carbonyl. If we are dealing once again with chlorine, it would become a chlorocarbonyl as the prefix, the substituent. Group number 5 would be the amide, which would be a carbamyl if we were to use it as a prefix. For 6, it is our nitrile, and this becomes the cyano group. Aldehydes and ketones would both be considered oxo substituents if we need to use them as a substituent. Alcohols, if it is a prefix, becomes the hydroxy group. And an amine, if it becomes a prefix, becomes the amino group. So once again, let's look at a couple of examples. So for our first one, our main functionality here is going to be the aldehyde. So we will name it as an aldehyde, and that is what it will dictate our numbering pattern. So the full name for this will become S,3-hydroxybutanal. Make sure it is an Al for the aldehyde functionality. That puts the alcohol unit on the 3rd carbon atom, and it would have S stereochemistry. For our second example, the highest priority functional group is the carboxylic acid, so that is going to dictate our suffix. The other groups will all become substituents for us. So the full name for this is going to be E,4-cyano, 4-oxo-but2-enoic acid. So E,4-cyano, 4-oxo, but2-enoic acid. So once again, the oic acid for the carboxylic acid, the E to tell us the stereochemistry around the double bond. The 4-carbon is the cyano group, and also the oxo group, the carbonyl as well. So once again, in totality, E,4-cyano, 4-oxo, but2-enoic acid. There are also a few common names that you will want to be familiar with. I have listed the common name, and then if there is an IUPAC name associated with it as well, you will find that in parentheses. So formic acid is where we have a carboxylic acid that is also attached to a hydrogen. So under IUPAC name, we only have 1 carbon, so this would be methanoic acid. Acetic acid also has the carboxylic acid functionality with 2 carbons, so this would be ethanoic acid. Benzoic acid has our benzene ring attached to a carboxylic acid, so this would be phenylmethanoic acid because the benzene ring is coming off of the carbon associated with the carboxylic acid. We also then have acetic anhydride, which would commonly be known to as ethanoic anhydride. where we have our two carbonyl functionalities separated by an oxygen for the anhydride, and each side there are only two carbon atoms. That's our ethanoic anhydride. Benzoyl chloride, also known as phenylmethanoyl chloride. So we have our benzene ring, and that is attached to our acid chloride. Formamide or methanamide is where we have our amide functionality, and it is attached to a hydrogen, so we only have one carbon atom in total. Acetamide or ethanamide is where we have two carbon atoms associated with our amide functionality. Both of those would be primary in nature. We then can also have benzamide or phenylmethanamide, where once again we have our benzene ring associated with a primary amide. You can have acetonitrile or ethane nitrile, which is where we have our nitrile group associated with one other carbon atom. Benzonitrile, which is so commonly referred to, it's really the only way that we name this compound, is where we have the nitrile group associated with the benzene ring. Formaldehyde or methanal is where we have our aldehyde functionality that is also attached to only one other hydrogen. So we only have one carbon atom in formaldehyde or methanal. Acetaldehyde or ethanal is where we have once again our aldehyde functionality associated with one other carbon atom. Benzaldehyde or phenylmethanal is where we have our benzene ring associated with the one carbon aldehyde unit. We can then also have acetone, which would be propanone. So we have a 3-carbon chain with the carbonyl in the middle. There's no locant needed for this ketone, because if we put the carbonyl in any other position, it would be an aldehyde and not a ketone. We can then have benzophenone, which is really diphenylmethanone. So we have our carbonyl functionality in between two benzene rings. Acetophenone is where we have our phenylethanone, so we have our benzene ring associated with a 2-carbon ketone. Phenol is our benzene ring associated with an OH. And once again, this is just the only way we really see this molecule named. Isopropyl alcohol, also called propane 2-ol, is where we have our 3-carbon chain and we have the alcohol on carbon atom number 2. T-butyl alcohol is methylpropane 2-ol as well. So once again, we have our 2-carbon chain with an oxygen and a methyl group coming off of the 2nd carbon atom. So this would be our T-butyl alcohol. Aniline is also known as phenylamine. So we have our benzene ring attached to an NH2, so phenylamine. So once again, with these common names, you do want to be familiar with them. They do pop up quite often, and you can use them on any exams for naming. So that is the end of our interchapters E and F, nomenclatures 4 and 5 information. You should be able to complete these problem sets now on interchapters D, C, E, and F.